We're going to start off looking at trig integrals with powers of sine and cosine. So we're going to be looking at functions like cosine cubed of x or sine to the fifth times cosine squared. So where we've got various powers of sine and cosine possibly multiplied by each other, but maybe just one of them. So there is a problem solving strategy given in the OpenStax book, and we'll kind of walk through this here, but the idea is um, if we're looking at our integral and we look for either the exponent on sine to be odd or the exponent on cosine to be odd. And if they're not, if they're even, then we're going to use likely one of our double angle formulas. So we'll probably take a look at that later, one of those double angle formulas, or maybe even in class. So let's take a look at an example. Let's look at cosine to the third power. And what we're going to do with this is rewrite it as cosine squared of x times cosine of x. And what we're trying to do here, so the overall goal is that we would like to set this up as a question that we can do with substitution. So if we left it like this in terms of cosine, and we tried to make u be that cosine of x that's being squared, right? Because here we have cosine of x being squared. If we tried to do that, the derivative of cosine is negative sine of x. And that's not in our integral, it's all cosines. So what we need to actually do is probably change some of our cosines into sine functions, because then we can do the substitution and we'll have the derivative of sine there. So we're going to kind of cross this stuff out because that's not what we want to do. So we are going to use the trig identity that sine squared of x plus cosine squared of x is equal to 1. And we're going to use it as cosine squared of x is equal to 1 minus sine squared of x. So remember, we can take that Pythagorean identity and solve it any way we want. And so we're going to replace our cosine squared right here with a 1 minus sine squared. So we're going to have the integral of 1 minus sine squared of x times cosine of x. And we do need that in parentheses because that cosine of x that's sitting outside here, that's being multiplied by our cosine squared. So we have to make sure it's being multiplied by all of the things that we're replacing our cosine squared with. So now I want to try the substitution again. Now we can take our u and make it sine of x, and then du is cosine of x dx, and that's exactly what's sitting in our integral. So we changed our cosines to sines so that we would have that derivative sitting there. And that's kind of the big point of what we're trying to do, is we're trying to be able to do a substitution. And so we're trying to leave sort of sitting here what the derivative of our substitution is going to be. So now if we do our substitution, we're going to have 1 minus u squared by plugging that sine into or plugging u in for sine, so we need to square it, and then cosine of x dx, that is du, and this is definitely an integral that we know how to do. It's just a quadratic, so we get u minus 1/3 u to the third plus c, and then we back substitute, so we get sine of x minus 1/3 sine to the third of x plus c. Now remember, with these, we can always check our answers by taking the derivative of this function that we got here. So if we take the derivative of this, we're going to get cosine of x, and then minus 1/3 times 3 sine squared of x times cosine of x. And then the plus c goes away. The derivative of that is 0. So if we take a look at what we have here, the 3 and the 1/3, those cancel out, which they should. And then we've got cosine of x minus sine squared of x times cosine of x. If we factor out that cosine of x, we end up with 1 minus sine squared of x. And we know from that Pythagorean identity that we just used up above that that's cosine squared of x, and this is cosine to the third power. So we got exactly what we started with. So our integral is correct. All right, let's do one more example of this. Let's look at sine to the fifth power times cosine squared. So how we're going to split this up is going to be just a little bit differently. And we do want to take the one that has the odd power and split off one of those. So sine has the odd power. So we're going to split off one of those signs. And we do that because this is going to be the derivative of u. So we're going to try to do a substitution. So we're kind of setting ourselves up and rewriting this. So it's going to be set to go to do substitution. So this is going to be the derivative of our u, meaning that u is going to be cosine of x. So what we've got left over here, the sine to the fourth cosine squared, we need to get all of this in terms, excuse me, of just cosine. Sorry, I'm getting a little craggly with my voice there. So again, we're going to use that Pythagorean identity. And excuse me, this time we'll solve it for sine squared of x is equal to 1 minus cosine squared of x. And we'll use this and plug it in there to our sine to the fourth. So again, I'm kind of doing this, outside of the integral just so that it's a little bit easier and we've got a little bit less going on. So that sine to the fourth, we can rewrite that as sine squared being squared. So now we can replace our sine squared with our 1 minus cosine squared. So our integral, inside our integral, we're going to have, and I'll rewrite this, 1 minus cosine squared of x, all of that mean squared, times cosine squared of x. Okay, so our integral is going to go from being sine to the fifth cosine squared. We're going to rewrite this as 1 minus cosine squared of x squared times cosine squared. And then I'm going to put that sine of x right at the end. Again, we can reorder these any way that we want because they're just being multiplied. And now I'm going to make my u be cosine of x. And then du is equal to negative sine of x dx. So again, that's why we pulled one of those sine functions off of our sine to the fifth power so that we would have this derivative sitting there for us. So the opposite of du is equal to sine x dx. So we've got to put a negative in our integral. So doing our substitution, we're going to end up with negative 1 times, and we can pull that way out in front too if we want, 1 minus u squared being squared times u squared du. So again, all of these cosine squareds that we have, we're going to put u in there for our cosine, so we're going to still have those being squared. So again, this is an integral that we can do. There's a little bit of, sort of algebra figuring that we need to do first before we do it. We have to, simplify our 1 minus u squared being squared times u squared. So we've got to do some multiplication. And you can do these multiplications in whatever order you want. I like to do the foiling first. So we get 1 minus 2u squared plus 4u to the fourth, and then that's times u squared. So in our integral, we're going to have u squared minus 2u to the fourth plus u to the sixth du. And again, I like to kind of, take this simplification, go off to the side, do all of that, and then put it back in the integral so that I don't have to remember to write the integral sign and remember my negative and remember my du, because it's really easy doing that to kind of lose that negative that's out in front. And if you want, at this point too, you could multiply through by that negative to just take care of that part altogether. So you don't have to worry about that either. So you just multiply through, change all your signs. And so we get negative 1/3 u to the third plus 2/5 u to the fifth minus 1/7 u to the seventh plus c. And you get a lot of these kind of 1/3, 1/5, 1/7 with these types of trig integrals. And we're going to end up with 1/3 cosine cubed x plus 2/5 cosine to the fifth x minus 1/7 cosine to the seventh of x plus c. I think this would take us a little too long to check this, but if you want sort of a fun experiment in simplifying trig functions, I challenge you to take this derivative and make sure that we get back where we started.